Hi guys, welcome to another lesson in Science 10, the chemistry unit. Today we're going to talk about naming compounds a little more. The previous video we had talked about naming ionic and molecular compounds, got into it briefly, talked about how they look, the transfer of electrons, whether it was a cation or an anion, and I mean how you change the ending of the second element, usually being when it comes to ionic, so the non-metal changing the ending to I'd. Now with naming compounds today, we're going to go into a little deeper, talk about a few more different rules that are going to come into play and start talking about some multivalent elements and polyatomic ions. So compounds with multivalent elements. So some elements have more than one stable ion. So we had talked about earlier before, we talked about isotopes and how usually some isotopes are not always in the most stable form. They can be radioactive, but some of the elements do have more than one stable ion. And so we have iron, for example, which is the symbol Fe on the periodic table. It has two stable ions. And so you have Fe2 plus and Fe3 minus. And the easiest way to tell right now if you have a stable ion or not is when you look on the periodic table, and if you can see more than one charge. So if you look at manganese, for example, you have a 2 plus and a 4 plus. That's showing you that you have more than one stable ion for that element. So elements with more than one stable ion are called multivalent elements. And ionic compounds containing multivalent elements must have Roman numerals in their names to indicate which ion is forming that compound. So when you're writing these out, you're going to be using Roman numerals in relation to the charge that you have. So example, chromium is multivalent. So chromium 3 sulfide would indicate that Cr3 plus ion forms that compound. And you can tell that it has a 3 plus charge because you have the Roman numeral 3 right here. Now you can find the Roman numerals to use in the name of a multivalent ions by using the subscripts in the formula. So example, an FeBr2, which is iron bromide, the subscript 2 after the bromine is a guide to the iron ion's charge. So positive and negative charges in an ionic compound must be equal. So according to this rule then, an Fe2 plus could pair up with two Br minuses to give the formula unit. So FeBr2 would be written out as iron 2 bromide. So that 2, you know, was a 2 plus charge from iron. And if you flip to page 44 in your textbook right now and you look at practice problems, you see number 2 on the side and tells you to write out the names of the following compounds. It'd be a great practice to do. So the first one is FeCl. So that means you have iron 2 iron 3, chloride. If you look at B, you have PbO2, so you have lead 4 oxide. And the reason for that one being that, and if we just minimize this right now, and we go to our board here, and if we look at the board, so in the practice problem, you have PbO2. Now we know that Pb can have a 2 plus charge, or Pb can have a 4 plus charge. We know also that oxygen has a 2 minus charge. So when we put our compound together, if we were to use this one, and this one, they both have the same charges, and we know that they would cancel each other out, so we'd be left with PbO. But that's not what we're given. We're given PbO2. So what we would originally start with probably is Pb, which is 4 plus, O2, or O, which is 2 minus, and we go to drop these charges, so the 4 would be dropped down here, the 2 would be dropped down here, cross-dropping those charges, we'd end up with Pb2O4. But we talked about in the last lesson how you need to take these ions down to their lowest common denominator. So we know that 2 goes into 2 once, so scratch that out once, and we know that 2 goes into 2 twice. And that's where we get this. Going all the way back up to here, and we get PbO2 because you don't have to write once. So there's an example. So you have a couple other ones. You have nickel 2, sulfide 3, and D and E. So the other examples that you can try. Now, polyatomic ions. Polyatomic ions are ions made up of several non-metallic atoms joined together. So they're kind of like a molecular compound, but not quite. So we kind of have a few differences here, and we'll learn about those as we're going on. But an example of a polyatomic ion would be the hydroxide ion. So in the compound NaOH, the sodium has a charge of 1 plus. The oxygen and the hydrogen together form the polyatomic hydroxide ion OH minus with a charge of 1 negative. And if you look for a complete list of the polyatomic ions, you'll see it on page 491 in your textbook. And just to show you what that looks like, if we look here, I just scanned it in. So this is page 491, and if okay, anyways, this whole table here is some common polyatomic ions, so that I'm circling the mouse around right now. And that is really useful for you to get to know and start to understand that when you're naming a compound, so if we go back here, to recognize that you have a polyatomic ion, that it's not sodium, oxygen, and hydrogen, it is sodium and hydroxide. Now, suffixes for polyatomic ions. So two most common suffixes used in naming polyatomic ions are ate and ite. So when we talked about naming ionic compounds and molecular compounds, I was telling you to change the endings to "ide." Now here's one of the major differences with polyatomic ions. You want to change the endings to "ate" or "ite." And if you look at that table on 491 of many of the common polyatomic ions, you will see that they all have endings of "ate" or "ite." And so when I give you an assignment and you're seeing that the ending of the second compound is "ate" or "ite, you know it's a polyatomic ion. And usually "ate" means more oxygen atoms, and ite means fewer oxygen atoms are part of the ion. So example, SO4 2 minus, which is sulfate, and SO3 2 minus is sulfite. And these suffixes do not actually tell you how many oxygen atoms are in the formula. Just ite usually means less than 8. If you look at the formula first when we're naming these, you always want to you first name the cation, and the cation usually is an example of ionic compounds is the metal. I mean, when we're dealing with the molecular compounds, it's a non-metal, but we'll get into molecular compound rules later. So you look at the cation first. So we're talking about an ionic compound joining up with a polyatomic ion right now. So look at the cation and you name it just like it is right off the periodic table. And then you go to when you name the anion or the polyatomic ion, that's what you name second. And if you look at on table A2.7 on page 45 in your textbook, it gives you some helpful hints there. And we're just going to go over a few of those helpful hints right now. So let's just delete this and get a new page. So on that table, the first example is calcium hydroxide. Now, some of the hints it says here, the polyatomic ion is often found inside the brackets. So we have brackets here, and sure enough, inside our brackets is OH, which is a polyatomic ion. Other things that it says here, we also look that the polyatomic ion is usually going to have more than one capital letter within it. An example of hydroxide, again, we have a capital O and a capital H. Whereas usually when we're just dealing with a single ion by itself, very, very rarely, if at all, are you going to find that you have a capital letter. You would never see calcium as C capital A. It is always just C little a. And I mean, those are two of the major rules when you're naming polyatomic ions and trying to figure out if you have a polyatomic ion in play. But there's a couple other rules there, so consult with that table as you're working through your assignments. Now, carrying on with some of the rules, again, they are similar to the rules for other ionic compounds. One difference is that the brackets may be used to show the ratio of the ions. So the subscript outside the brackets applies to all the elements inside the brackets. So example, Fe2 bracket SO4 3. So if you flip to page 46 in your textbook, if you have your textbook in front of you, there's more practice problems on the side with the examples in there, and that goes through how to determine what's applying to what. But if we look at, we go take this example, Fe2SO4 3. So if we write this right here, and we have Fe2SO4 3, what I'm talking about is that right now I have, in this little part here, I have 2, okay, Fe, or iron ions. So 2 Fe ions. Now, oh, I forgot the 3 out here. Now, what we are talking about with the brackets is meaning this 3 applies to everything that is inside the brackets. So what it's saying is that I have 3 SO4s, or an SO4 there, an SO4 there, and an SO4 there. So we have 3 of those, and you can count that as a single unit together. And that's the ending, and just a quick lesson on naming compounds again, carrying on with the idea of naming ionic compounds, a little bit about molecular, but now bringing in the idea of how polyatomic ions come into play. So again, I really suggest that you get to know that table in the back of your book on polyatomic ions, and you also do those practice problems, and keep a watchful eye out for those hints on page 45 in your textbook, table A 2.7. Hope you learned a little bit about today. Thanks a lot.